Hello friends, welcome to the solution of test series 3 EC, and it's for 2 marks and comes under topic receiver. Okay, let's state the questions. For a super heterodyne receivers having a no RF amplifier, the loaded Q of the antenna coupling circuit is 100. So Q is given to be 100. It's given in the question. Now, if the intermediate frequency is 455 kilohertz, it is given. So IF frequency is 455 kilohertz is given. Okay, the super heterodyne receiver is IF is 455 kilohertz. The super heterodyne receiver is to be improved for the high frequency reception so that its image rejection at 25 megahertz is as good as it was at 1100 kilohertz. The value of loaded Q which RF amplifier for this receiver would have to have. So I have to find the net Q. I have to find the net Q in the circuit which will give me same image rejection ratio. That is, mind it, same image rejection ratio is demanded as in 1100 kilohertz as in 25 megahertz. Now you know that let's calculate. Let the image first of all, let the image frequency rejection ratio, let the image frequency rejection ratio of the loaded RF amplifier which is to be added is A dash. Okay, suppose this is nothing but this is the image rejection ratio which is to be added with 25 megahertz. Okay, with 25 megahertz, so that it is equal to the same, it will give the same image rejection ratio as a 1100 kilohertz. Okay, let's find the image rejection ratio first at 1100 kilohertz. That is, we have to find the, let's denote it to be alpha 1. It is for 1100 kilohertz. Now, as you know that image rejection ratio alpha is nothing but under root of 1 plus rho square q square. Okay, where rho is equal to FSI image frequency divided by Fs minus signal frequency minus signal frequency upon image frequency. Okay, and what is FSI? FSI is given as signal frequency plus twice of intermediate frequency. So these are the formula which is to be used. So it's an important formula. Okay, now for the first case, FSI is 1100, which is signal frequency Fs, plus 2 into 455 kilohertz given, that is intermediate frequency 2 IF. So it's equal to nothing but 2010 kilohertz. When you calculate, it comes out to 2010 kilohertz. Now when you calculate the rho, it is equal to FSI 2010 by 1100 minus 1100 by 2010, comes out to be 1.28. Okay, what is the alpha then? Alpha comes out to be 1 plus 1.28 whole square into 100. See please, Q is given 100 square 100 square. When you calculate, it comes out to be 128 nearly. Okay, this is nothing but my alpha 1. Now let's calculate in the same pattern. In the same pattern. Okay, let's calculate alpha 2 at 25 megahertz. So FSI comes out to be 25,000 kilohertz. Okay, 1000 K plus 2 into 4, 55K comes out to be 25910K. Okay, rho comes out to be how much? Nothing but my 25910 divided by 25000 incoming frequency minus 25000 divided by 25910, which is equal to 0.0715. And for this alpha 2 comes out to be root over 1 plus 0.0715 whole square into 100 square. Same formula, this formula. Okay, this formula, yes or no? So this alpha 2 comes out to be how much? It is 7.22. Okay, so according to the requirement, what is the given? Now what is the asked in your question? The question says like this. Okay, read the question again please. The question says like this, that is, the super heterodyne receiver is to be improved for the HF reception so that the image rejection at 25 megahertz is as good as 1100 kilohertz. So what you have to do is just multiply your sum factor, that is sum alpha at 25 megahertz, which is equal to this alpha 128, that is nothing but my alpha 2 into A dash. See please, image frequency rejection ratio of the loaded RF amplifier to be added is nothing but my A dash. So A dash previously assumed. So it's a previously assumed. So see here please, it's a previously assumed. Okay, is equal to how much? Alpha 1. So what is A dash now? A dash comes out to be how much? A dash comes out to be 128 divided by 7.22, which comes out to be 17.72. This is my alpha dash. Which will gives me no frequency, that is no image frequency. But my dear friends, this is not asked in your question. That is, I have to find the value of Q. Now let's apply the formula, that is same formula, this formula. Now I have this alpha, I have rho, and I have Q. I have to find out the value of Q. Okay, so what is the rho for this? The rho for this is nothing but my same 0.0715. So rho is known, new alpha is known, only you have to find out the Q. So can you find out please? Let's do here. That is nothing but my 17.72 is equal to root over 1 plus q square into 0.0715 whole square. Yes or no? And this gives me q to be equal to how much? 247. So this is my answer. So the only hurdle for this question is just you have to match this rejection ratio with another rejection ratio. So for matching I have to need just one alpha dash to be matched with 25 megahertz frequency, same as 1100 megahertz frequency. So just find alpha 1, find alpha 2, and then match alpha 2 into alpha dash is equal to alpha 1. For this, just find the loaded Q. So loaded Q comes out to be 247. Hope answer is clear.